going to tell me, how can I put 3 and 2 together? In what math way can I put 3 and 2 together to get 9? Somebody tell me. Raise your hand. Josh. 3 to the second. Very good. 3 to the second gets you 9. Kudos. What is a way that I could put 2 and 9 together to get 3? Any math way you want to do. You're all over today, Josh. That's right. The second root of 9 would be 3. That's very good. The tricky part comes, how are you going to put 9 and 3 together to get 2? I'm sorry? Yes. That's the entire point of what we're doing today. You would use a logarithm, and it would be written like this, and we'll talk more about it in a second. A logarithm is its entire function. A logarithm is used to say, if you have a number at the base, we're going to call this the base all day. It's something that has an exponent, but the number itself is going to be called the base, or letter, or whatever it is. If you have a base, and you know what you want it to equal, 3 to the something equals 9, but you don't know the exponent that you need to raise it to, that's when you use a logarithm. So we're just going to spend a few minutes today practicing logarithms and understanding why they exist, and that is why they exist. Questions about any of my intro about? Let's just look at a few. We're going to jump straight into the problems in the book. Now the first 2 sections, go. Okay. The first 2 sections were the problems, which I will pull out now. Notice, they do not say solve in the directions. They simply state, write each equation in its equivalent exponential form. You are not solving anything, you are just rewriting. The base of all these logarithms is the base when you're doing an exponent. So number 1 would be 2 to the 4th equals 16. When you're working with logs, the number it equals is always your exponent. That's the entire purpose of a log, is to find an exponent. So number 1 would simply be 2 to the 4th equals 16, and that's it. Number 3 would be 3 to the x. Oh, I said that wrong. 3 to the second equals x. You don't have to solve these. I know some of these are very simple solves. That's not the point. Yes, always. And the little number, the base, is the base when you write it with an exponent. Well, what's number 5 going to be? Very good. Again, it's not your job today to solve, even though you would just take the 5th root from here, but not your job. Number 7. Now, on number 7, it's just backwards, but it's the same thing. Who wants to tell me that one? Exactly. That is all you have to do on this first one. All right. Were there questions about where we got any of that before I move on? Okay, skipping on ahead then. The next section, same exact thing. The only difference is we're working in the reverse order. We're taking a math equation and we're converting it to a logarithm equation. Now we'll do the first ones, and then the other ones will take a little bit more explanation. But so, like number 9, I'll do the first one. Remember, in a logarithm, the exponent is the answer. So the 3 is going to be out here, and it's log base 2 of 8 equals 3. And don't worry about negative exponents and all that stuff right now. That's not really the point. That was number 9. Log base 2 of 8 equals 3. You're solving for the exponent every time. So like 11, you know you're going to be equaling negative 4. And what will the log base be? 2 of 1/16 equals negative 4. Before we go any further, maybe we should look at a few exponential things. What does a negative exponent do? Can somebody tell me? What's the negative exponent do? Yeah, it flips it. When I taught Algebra 2, I'm not going to today, so I didn't even think about it, but I used to sing the Michael Jackson song Beat It, but I would put in the word flip it. Every time you see a negative in an exponent, it just means flip it. If it's in the top, you put it in the denominator. If it's in the denominator, you flip it to the numerator. So if you had like 3 to the negative fourth, that is the exact same as 1 over 3 to the fourth. If you had 1 over 2 to the negative 7, that's the exact same thing as 2 to the 7th. So that's why 2 to the negative fourth is the same as 1 over 2 to the fourth, hence it's 1 over 16. One other one I want to look at, what is a fractional exponent? If I said 8 to the 1/3, what's that mean? That's right, it's a root. This is the third root of 8. Or if I were to say something like 4 to the 4/5 power, the numerator is its exponent, and the denominator is its root. It's just important to know what these exponents are if you're going to understand why these logs work the way they are. That's the only reason I'm telling you this. So, moving on. 13. You want to convert, if they don't give it to you in exponential form, convert it to exponential form first. 13 can be rewritten as 8 to the what? To the 1/3. Now we'll rewrite that as, what's our base? Of 2 equals our exponent. Very good. Looks like that's the trickiest one on the page. Everything else just gives you an exponent. 19. What would that one be? Eeny, meeny, miny. Tyler Bercy, what would 19 be? You always solve for the exponent when you're doing a log. So it would be log base 7 of 200. Everything else is good though. You just got those two backwards. Questions on anything from that page? That is all you have to do. No solving. Now, the next section, I will allow you to use your calculator on exclusively. There's not going to be one of these on the next test anyway. It'll be more towards the end of the year, and we'll talk about it more at the time. But after about the 3rd or 4th chapter, I don't know if I told you guys this, you can start using your calculators full time after just a few chapters. I only don't let you use them in the beginning because I want you to have a good foundation for the rest. But the rest of them, like this bottom section, that's as far as we're going today. You're just going to solve them. You're welcome. Now, you can't put in a base into your calculator. There's no button for the little number in the bottom. So here's how you're going to have to do it. Let's see. Let's get out later. I'll show you. You have to do, now, because this number right here doesn't really have a name, and we've been calling this a base all day, somebody once suggested that I just call this the acid. So that's what I'm going to do. Acid and base, they just kind of went together. They're not actually called that, but they don't really have a name. I even wikied it. There's no name. So, to punch that into the calculator, you would do log of 16, log of the acid, divided by log of the base. And that's it. Boom. The answer's 2. And that's what you're doing on all those. You're just solving them. That implies that 4 to the 2nd equals 16. It is. It's not so bad. All of these you can punch straight into the calculator. Let's see. Now, you just have to think about it. 4 to the what is 16. Some of them are not nearly that easy. Let me ask you this. Hypothetical question. Actually, maybe there's one on here that's like that. Yeah, look at number 39. This is hilarious. 5 to the what is 5 to the 7th? 7. Yeah, ones like this, they're just self-explanatory. So staring in space. I don't even know why they added that in there. I guess they're thinking your way. 5 to the what? Yeah, so the answer to that would be 7. What about 41? Good question. Well, regardless of what the base is, let's do a one with meter numbers, and I think 41 will all of a sudden become very apparent to you. Let's look at 4 raised log base 4 of 16. Log base 4 of 16, just like up here, what is this going to be by itself? 2. Now, what would 4 to the 2nd do? That's right. Whenever you have anything like this, where the base is the same as your big base, this is going to be your answer. Now, this one would be a little uglier if you were to work it out like that, but this is essentially what's happening. In the numerator, you're just kind of working the problem backwards, and then you're applying it to the same number, so it's like multiplying and then dividing by the same number. So this would just be 16, and this one would just be 19. Yeah. And I'll show you how to punch that in the calculator too. 42? Yes. But again, you can still just punch this in the calculator. That is 8 raised to the log, remember, log of acid divided by log of base. So log of 19 divided by log of 8, 19. The reason you can't put in a base is because logs are most commonly used with scientific notation. And so they have a natural base of 10. So because log is just pre-programmed into your calculator with a natural base of 10, that's how you have to do it. Natural log is the exact same thing as log. The only difference, that's why above log, by the way, in your calculator says 10 to the x, because it has a natural base of 10. Whereas natural log has the same exact function as log, but it has a natural base of e, which is used a lot in physics, which is why natural log is mostly just used in physics. But if you see natural log, you won't see it today, but if you see it in the future, just know it's the exact same thing as a logarithm. Okay, is there another one on this page somebody wants to see? Pick an odd one. Pick one. 32. Pick an odd one. How about 31? So, good question. Well, there's two ways you could do it. Two ways. First way, without using the calculator, but you could, is rewrite this as an exponent. Let me take that one away so we have more space. So, because radical 2 is in the denominator, that little fraction right there is the same as radical 2 to the negative 1. Also, because a root is just a fractional exponent, this is the same thing as 2 to the negative 1/2. So really, you're taking log base 2 of 2 to the negative 1/2. So it's just going to be negative 1/2. It's just going to be whatever the exponent is. But again, you could just plug this into the calculator if you prefer. Log of the acid, square root 2, close, divided by log of the base. Big thing today is count your exponents. Your parentheses. Make sure you don't make a parentheses there. And sure enough, negative 1/2. So either one. Other questions from anything on that screen you want to see? Log of the acid divided by log of the base all day. Okay, that's it. 2 through 42 every other even. It's 11 problems. That's your assignment for the day. And just put at the top log. Just write log at the top of your paper instead of the chapter number. 310, I think. 310. Oh, 410. 410. 2 through 42 EOE. Page 410, 2 through 42 EOE. No. And when you're done, watch some funny commercials and some TV shows and just chillax. Sure, I guess if you want it too short.